What's good, everybody? In my video today, I'm going over a problem that I totally screwed up in my last live stream, talking about graphing linear equations and quadratics and absolute values. Check it out. It's linked down below about the 23 to 25-minute mark. So what I wanted to explain was this problem, because I see students struggle with it if they forget about transformations. But before we get here, let's talk about the parent graph. So the first 3 points, when we talk about the parent graph, we're going to have 0, 0, 1, 1, 2, 4, and 3, 9. Just remember that when we plug in a x, right, this is the points we're going to get, right? We know we plug in 2, we square it, we get 4 for the y, and so on. So when we look at our second example now, what I see is students will say, hey, I could factor this, and they'll go ahead and break it down to x plus 2 times x minus 2. And then we know we're going to get intercepts of x is equal to -2 and x is equal to 2. So as a result, what I'll see students do is they'll go ahead and they'll graph those 2 points. But for some reason, they now are saying to themselves, hey, Mr. Peters, what about the axis of symmetry, right? Because we're missing that b term in the quadratic formula. So we couldn't do the opposite of b over 2a to figure out what our x is, which would help us then find the vertex. So what we could do instead, right, is just understand the relationship. So when we look at the graph and we shift this down 4 units, right, 1, 2, 3, 4. When we use transformations, another way that we could figure those points out is just kind of remember the rise over run. So the first point, we go up 1 and over 1 from this vertex, which is 0, -4. So if I went up 1 over 1, my new point would be +1 and -3. Then if I wanted to get another point, I could then go back to the vertex, and I would go 2 to the right and then go up 4, which would bring me to these 2 points right here, right? Those solutions. So I wanted to just make sure that I explained that relationship to you guys, and I put that at 1, guys. I'm sorry. I just wanted to make sure I explained that relationship to you guys so that you could see that trick. And this normally only works when there is not a lead term, a lead coefficient in front of x squared. So there won't be a vertical stretch or compression, okay? And if we just pay attention to the y's, all of the y's changed by that transformation of 4. We went down 4, so we have -4 for the vertex. And then when we look at this point here, when we go down 4, right, we're going to get 0 for our y. So hopefully you guys found this helpful and you understand what I was talking about in the video. Anytime you make a mistake, guys, just laugh it off and understand it will happen. Thank you guys so much for joining me today in Algebra 1 with Mr. Peters. See you next time.